All right, so I think this is going to be the last one for 6.3. Probably for everyone who's been watching, you're going to hope this is the end because this section's been going on for a while. So the other thing we can do with these rotations and volumes is we can set up integrals to find volumes where we're doing rotations that are not just around the axis. So we've exclusively done x-axis, y-axis kind of rotations. So you can actually set these up and do rotations around literally any line you want. You just need to then adjust your formulas. The basic concept still holds, right? It's just going to look a little bit different. So let's consider the region bounded by x squared and y equals x squared and y equals 2x. So 2x, right, it's going to be a line up 2 over 1, up 2 over 1. X squared, they're going to essentially meet at 0, 0, and 2, 4, right, 2 comma 4. So you get this kind of sliver. And let's look at the volume of the region created when you sort of rotate this around the line y equals minus 2. So I have that sort of picture drawn. Y equals minus 2, right? Horizontal line, so 2 under the axis. So I'm taking this region, and what's happening is I'm sort of rotating everything, you know, not just around the axis, but now it's rotating around y equals minus 2. So the rotation is sort of shifted down by 2. In the most general kind of basic sense, what that's going to do to the radius at each kind of individual x value is the radius is going to be 2 bigger than it used to be, right? Because now instead of just going from the function down to 0, you're going down to minus 2. So you have this extra distance here. It some sense will show up for us as literally plus 2 for each of the radius values. I'm just going to do setups again. We won't go all the way through to find the actual volume here. And this is an inner and an outer. This is a washer situation. So we're going to set it up washer style. So this is washers. So we need kind of big R. And we need little r, right? We need sort of inner and outer radius values. The interval is x equals 0 to 2, right? These are sort of y equals functions. This is a horizontal line that we're rotating around. So the dx situation is still going to work. This is still a rotisserie style rotation. So we're going to do an x interval. We want y equals functions. We want it to be, right, with respect to x. We want dx on the end. So the thing we need here is just to adjust our radius values. And what I said before is essentially literally all we're doing is we're adding 2 to our radius here. You might say, but this is minus 2. What's happening here? In some sense, what you're finding for your radius is it's the difference, it's the distance between your curve and whatever you're rotating around. So you could think of it as, you know, the outer radius would be the distance between, right, 2x and negative 2. So your kind of difference there would be sort of 2x minus negative 2. But of course, that's just 2x plus 2, right? You know, it's 2x plus the 2 extra units that you're getting underneath. Your inner radius, right, is going to be the same thing kind of conceptually, right? It's the squared function minus this negative 2. But then in the end, that's x squared plus 2. You can do a couple quick like test points if you think of like, well, what would the value be at you know, x equals 0. So the radius for either of those would just be from 0 to 2 would be 2, and that would check out. You know, if the x value is 1, what should the radius be, right? So 2x times 1 is 2, but then the distance down here should be 4. 2 times 1 plus 2 is 4, right? X squared is at 1. The radius there would be 3. 1 squared plus 2 is 3. You can kind of do some spot checks to make sure that you have the right setup. But, you know, in theory, your radius here it's the same kind of concept of the sort of outer to the inner, right? It's sort of what's the distance between your kind of outer point and the actual line that you're rotating around. So that, you know, the distance is going to be, the difference here would kind of be a subtraction is a way to sort of think of the setup. you know, conceptually, if you're sort of just comfortable with saying, well, what's the, it would be the function values just plus 2. That works, right? I mean, I guess in some sense, there's no reason not to just think of it as simply as that. So my volumes here, the interval runs from 0 to 2. So this would be pi, right, big R squared minus pi little r squared. This is dx. So that's going to run 0 to 2 pi. So my big R, right, is the quantity 2x plus 2, quantity squared minus pi times my little r would be x squared plus 2. Again, quantity squared. And these are dx. Those can be just FOILed and expanded, right? But that's the basics of the setup. You know, I want to sort of keep us moving a little bit and not get really bogged down with, you know, expanding out and sort of, you know, getting multiple steps sort of deep into the thing. So that's going to be my setup. That's what I did. I probably should have said, I said, find the volume. Let's say set up the volume of the region rotated around y equals minus 2. I'm going to go on to the second page just to sort of get a little bit more space to work with. I'm going to do the same region, but let's do a rotation now from the other perspective. So let's do same region. So that was y is x squared and y is 2x. But let's rotate it around. So let's do a vertical line instead. Let's do, I don't know, x equals 5 or something, let's say. So let's get a sketch going again. Somebody who's looking to make a bad joke might say, you know, one thing you got to watch out with on these volume problems is they can be very sketchy. They can be very sketchy. And then you would probably boo them. You would probably just rain boos down from on high, because that is a terrible joke. So what are we doing here? This guy's like that. So we got to line up, and then our interval goes like that. And then we're going to rotate around. What did I just say? X equals 5. So 1, 2, 3, 4, 5. So that's our rotation around x equals 5. This is going to be a vertical style rotation. So this is going to be a rotation that's similar to rotating around the y-axis. So that means my setup is still going to be kind of outers and inners. But this is going to be a dy setup, which means I need x equals functions. So I need those two functions rewritten. My interval is going to run right along the y-axis from 0 to 4. My functions, so if y is x squared, that would mean that x is square root of y. And this is just going to be just the regular x equals square root of y. It's not the negative version or anything. This is still just in the first quadrant. So that syncs up and is fine. For y equals 2x, then that means the x value would be, right, y divided by 2, or, you know, we think of this as whatever, 1/2 times y. So I'm actually going to label these up on my picture. So this is, right, x is root of y, x is 1/2 y. So that's the visual. So what's happening here with my radius values? So if I'm rotating around like this, right, what happens is I'm going to get, you know, kind of big chunks like this. My discs are going to be here. I would get kind of a mirror image over on this side. And in theory, right? I'm kind of getting, you know, washes that look something like that. I'm not sure how well these drawings come across. Probably, maybe I'll have to look this up and see if I can put some links in. There probably are some better visualizations for some of this stuff than what I can just do on paper. In any event, so my kind of washers here, I would need an outer radius and an inner radius. So the setup here is going to be, my outer radius should be that difference between x value 5 and the line 1/2 y. You know, you can be a little forgiving here in some sense because these are going to get squared. You know, in theory, what you should do is you should watch, you know, kind of what's your outer, what's your inner. You want to have it set up so that you're kind of getting positive radius values so that they make sense. And, you know, in some sense, maybe what it would help to do is to sort of visualize it like this, right? So it's the distance from here to here. So that's the difference from 5 down to like 1/2 y. So I would say let's write this as, you know, your outer radius would be 5 minus 1/2 y. Your inner radius would go then to the root, right? 5 minus root of y. Something kind of like that. Again, if you kind of pick individual values, everything should sync up, right? If your y value is 0, you're going to get positive 5 and positive 5 for both of them, right? If your y value is 4, right? 5 minus, you know, 1/2 times 4, 5 minus 2 is going to be 3. 5 minus root of 4 would sort of also be 3. And then if, I don't know, we picked something like 1, you know, 5 minus 1/2, you'd have sort of a 4.5 there, right? 5 minus root of 1 is 4. All that stuff would sort of sync up. Again, this is a little forgiving because you're going to square it. You know, if you flip these around and you did 1/2 minus 5, technically you would still get the same answers. But the next section, the volumes will not quite be so forgiving. So it is important to make sure that you're getting right kind of positive radius values here, and you're sort of setting up your subtraction and your kind of differences such that you would get positive values. That said, now that we kind of know the individual pieces, our volume here, the setup, should be the integral. So it's a y interval, right? So from 0 to 4 on the y-axis. So pi times this big radius, 5 minus, you know, quantity 1/2 y squared. So that's going to be like a FOIL situation, minus quantity 5 minus root of y, quantity squared dy. And that's another one. I'm just going to leave it like that for now, right? Having that setup is a big chunk of the work here that kind of conceptually gets us over the hump. What you would need to do next as far as, you know, evaluating this integral is square and kind of FOIL both of these out. You know, even this one with the root, you would have, you know, 25, right? Obviously, 5 times 5, negative 10 root of y, but you can deal with that. That's just a y to the 1/2. And then, of course, you know, a negative root of y times another negative root y would just be a positive y to the 1. So that stuff would clean up okay. And yeah, that'll kind of get you on the path. This one in particular would definitely take a minute to actually do the full integral and evaluate, but it's all doable stuff. It's similar to sort of work we've done before. And again, I think the big thing here conceptually is just making sure you understand the setups and where all these different pieces are coming from. So that's our setup for the volume here, doing this sort of vertical rotation around x equals 5. That's what we got. Anyway, have fun, and we'll see you in the next video.